Sit. All right, AP Calculus. This is the optional lesson 6-3. I'm anticipating that maybe one or two of us are going to be actually doing this on my test or on the AP test, but I'm hoping that you know that you're only doing this if you have extra time. So today's date is January 6, 2021. Our objective today, Andrea, is to
find the specific particular solution to the differential equation.
Yep, there it is, to do this actual step 4. So step 4 is to isolate. Again, the previous 3 steps, we had separate the variables, then we had integrate, and then we had evaluate. Evaluate being plug in. Then isolate. So isolate just means get y by itself. So let's write that down. Get y by itself. So there's kind of four steps to do this. So first you have to find C. So find the value of C. And this is already done in step 3. This was step 3 kind of. But remember yesterday where we had like a bunch of logarithms added and subtracted and it was kind of hard. So doing that might be hard, and it typically will be. I'll show you the methods to find that. And then for part B, you need to plug C back into your equation. Oh my gosh, can't spell. Equation. You need to actually isolate y. Isolate y to get it into y equals form. And then finally, step D, which is pretty critical, you need to verify your initial conditions again. And I'll sound like a broken record, but I will say it over and over again. This is 1 or 2 points worth of work. So how do we do that? I'm going to go through all 4 steps for this problem. This one is very, very similar to a real AP question. So it actually might be one. I don't remember how I designed this one. So find the particular solution, which if you see those keywords, particular solution, you are going to be doing these 4 steps over and over again. All right, let's do step number 1. Fiona, what's step number 1? Fiona, are you there? There you are.
You cross multiply?
Yes, but what is the step called? Do you remember? They end with 8, like integrate, evaluate, isolate. This one is separate. And one of the steps in separating, as you said, is cross multiply. So we'll label this separate. And we can't quite cross multiply because there's no fraction over here. So tell me what to do, Fiona.
Do you put it over 1?
You do, yeah. So put it over 1. Now it's a fraction equal to fraction. Cross multiply. What do you get after cross multiplying?
dy equals xy to the 3rd dx.
X, y, the 3rd, and then dx. We cross multiplied that direction. Perfect. Okay. And then from here, I haven't finished my separating yet, Fiona. So Fiona, what's my last step to truly get all of my y's on one side, all of my x's on the other?
Divide by y to the 3rd.
So divide both sides by y to the 3rd, divide by y to the 3rd. And our final separation looks like what?
1 over y to the 3rd dy equals x dx.
Perfect. There it is. All right, step 1 done. We're on to step number 2. Step number 2. Just do it right here. Perfect. Integrate. Oh shoot, I meant to ask you what that is, but I gave it away. Integrate. And Teflon, were you able to watch the video for yesterday?
No, I still have to do that.
Okay, cool. Andrea, help us.
It's the integral of 1 over y to the third dy equals the integral of x dx.
Perfect. Go ahead and do the integration for us, please.
Then it would be we could do the y to the -3,
Exactly. Yep.
and then it would be y to the -2 over -2.
Y to the -2 over -2. Good. There's the left-hand side. What about the right-hand side?
X squared over 2.
Squared over 2. And make sure you get your point by doing
Plus c.
plus c. Perfect. All right. There it is. Integration is done. We're on to step number 3. Step number 3 is to do what, Fiona?
Evaluate.
It is evaluate. And Teflon, you can actually do this for us. I'll walk you through it. So evaluate is just a fancy way of saying plug in. Plug in our initial conditions. Our initial conditions up here is f of 1 is equal to 2, which means our x coordinate is 1, our y coordinate is 2. That means sub 1 in for x, sub 2 in for y. So in this, in Andrea's equation right here, I want you to sub 1 in for x, 2 in for y. You can zoom out so you can still see that. Tell me what to write, Teflon.
Would it be 2 to the -2 over -2
Keep going, yep.
equals 1/2 plus c?
Perfect. And we'll zoom in here and I'll help you continue. 2 to the -2. I don't like negative powers personally, especially when I'm just dealing with normal numbers instead of variables. How can you simplify 2 to the -2 over -2?
Do you like take out a 1 or something? A -1?
Yeah, so you can get rid of the negative by doing what to it?
I don't know.
I'll give you a hint over here. So if I have 2 to the -2, that's equal to 1 over 2 to the power of +2. How's it going to help you reduce this?
Would it just be 2 over
So if we move this to the denominator, what's left over is a 1. So I can just write a 1 in the numerator. But what is everything that's in the denominator now? We have this thing and what was there before?
the -2?
Yep, so I have 2 to the 2 times this -2. And what is that going to simplify to?
-8.
Perfect. Yep. So we have -1/8 is equal to 1/2 plus c. Nice. And I might as well start solving for c as well. I'm still going to pick on you some more, Teflon. Solve for c.
Do you subtract 1/2?
You do indeed. So you're going to have -1/8 minus 1/2. And how do I do that?
You get common denominators.
Perfect. How?
Multiply top and bottom by 4.
All right. And was that going to make our answer?
-5/8.
Okay, 5/8. So we come down here and say c is equal to -5/8. Perfect. Thank you. All right. And then we're on to step number 4. And I guess step number 4 was kind of doing what Teflon just did in that last step, solving for C. I know I just said that in our instructions up here. Step 1 is to find C, which is kind of step 3 too. I guess there's a little bit of overlap. So let's move on. What's going on with my pen? 4. Step number 4. What is step number 4, Fiona?
Isolate.
It is indeed isolate. And lucky us, we're basically there. What do we have to do? We found C, check. We need to plug C back into the equation and then isolate for Y. So can you do these 2 steps for us, Fiona?
Do I plug it in where we plugged in y and x, or where it's still y and x?
Yeah, where it's still Y and X. So we'll go back to Andrea's equation.
So then y to the negative 2 over negative 2 equals x squared over 2 plus or minus 5/8.
Minus 5/8, perfect.
And then you multiply by negative 2.
Okay, what do you get after that?
Y to the negative 2 equals x squared. Would it be negative 2x squared over 2?
Exactly, yep.
Minus, or would it be plus 10/8?
Plus 10/8, yeah. And you can simplify that, right? So Y to the negative 2 is really equal to,
negative x squared plus 5/4.
beautiful, all right. And this is gonna be a little bit tricky now. So you need to solve for Y.
1 over y squared
Perfect.
equals the same thing.
Yep. And then this is where there's a little trick, and I'm curious if you know it or not. What do you think you do from here?
Is it like you like multiply by the square root or something?
Not quite. So right now we want y squared in the numerator, but it's in the denominator. So what we're allowed to do, assuming that this expression is not 0, which I hope that's okay. Is there anything up here that can verify that that's not 0? Not really. Let's go ahead and let's assume that this is not 0, and I'm going to take the reciprocal of both sides. Essentially, I'm just going to flip both sides. So flip the left-hand side, and I get y squared. Let's change the color here. Y squared over 1. Flip the right-hand side, and I get 1 over negative x squared plus 5/4. Again, the reason I have to assume that this negative x squared plus 5/4 is not 0, because otherwise I would be dividing by 0, which is a mathematical sin. I cannot do that. So I've made an assumption. Hopefully it doesn't come back to bite me. But now I have y squared in the numerator, which means I can kind of ignore the 1 down there. And then finally, Fiona, how would I get y by itself?
Take the square root.
Perfect. Yep. So what is that right-hand side going to look like? I know the left-hand side is just y.
The square root of, can I put 4 on the top?
No, you can't unless you somehow get like denominators, combine that into one fraction, and then take the reciprocal and put up there. There's a bit of work that's required, but you could do something like that. We'll just leave it
the same.
Close, but not exactly the same. I'll talk about y in a sec. So negative x squared plus 5/4. So there's 2 things that need to change here. Well, they don't need to. One of them you do need to. The first thing that you have to change is this has to be plus or minus. Whenever you take a square root, you have to have a plus or minus. And you will eventually choose one or the other, and I'll talk about how to do that in a little bit. but make sure you have the plus or minus. And then the other thing that's kind of cool is when I have, and let me do this off to the side. Do I have any notes off to the side? Here's some room. If I have the square root of 1 over a, or 1 over x, it doesn't matter what variable I have. This is really equal to the square root of 1 over the square root of x. It's the power rule. It's one of the rules of exponents. Not a power rule, it is a rule of exponents. And then this turns into, well, the square root of 1 is just 1. So this is really 1 over the square root of x, which means this giant square root, I really only need the square root in the denominator. So I can rewrite this square root by saying it really only belongs in the denominator. It's kind of silly to take the square root of the whole thing. Okay, so Fiona's been doing a lot of work. I'm gonna switch it up. Andrea, you're gonna help us out now. You're doing our final step, which is step D. You're going to verify the initial condition. What that means is just, again, evaluate, plug in 1, plug in 2 to check whether we should be doing a plus or if we should be doing a minus. So again, x is 1, y is 2.
Would it just be 2 equals 1 over the square root of -2 squared plus 5/4?
I think x is 1, right? So it should be
1, yeah.
So -1 squared plus 5/4. And then you have to do a little bit of simplifying again. Let's zoom in here to get some help. So 1 squared is 1. I know that was really hard. And 1 times a negative is -1. So this thing right here is really saying -1. If it was -1 quantity squared, that would be a +1. But rules of, your PEMDAS, your order of operations in the state, you have to do exponents and then multiplication. So this is really a -1. And -1 plus 5/4 is what?
1/4?
1/4, perfect. And what is the square root of 1/4?
A half?
1/2. So this is really saying 1 over 1/2. And this is really a keep it, change it, flip it. Keep the 1, change it to a multiplication, and flip the 1/2. So if you keep it, change it, flip it, 1 divided by 1/2 is
2.
2. So now you, Andrea, will make the conclusion. Should this be a positive or should it be a negative?
Positive.
Should be a positive, yeah, because we got a positive 2 here. Well, I should say that 2 doesn't matter. This was a positive 2 over on the left-hand side. If this was a -2, then we would have chosen the negative. So we'll choose the positive. And finally, we'll write our final answer of y is equal to a positive. So I just leave it blank. 1 over this square root of, and I can switch this around and be fancy about it. I can say 5/4 minus x squared. And I can box it. I could have just rewritten -x squared plus 5/4, but I think that looks cooler. Whew. And I will reiterate again and again, we probably got 1 or 2 points for doing that. Even though just by doing steps 1 through 3, you got like 6 or 7 points. So I think hopefully now in the back of your mind, you're like, that's the reason that John Wynn thinks that this is optional. And I agree. Like if you're gamifying it, it's not worth doing all this work. And especially once you see the second example, this one is even harder. And this is like one of the hardest types of questions that I have seen on the AP test. And about 50% of them look like this. So quite a few of them. It's not like, it's rare. 5% of them. It's like quite a few of them look like this. Here we go. Whew. Find the particular solution. I see the words particular solution. I'm going to be doing those 4 steps and I'm going to go rapid fire because I want to give you some time to do the homework. All right. Step number 1 is to do what, Teflon?
Separate.
There it is. Separate. We don't have a fraction, so I'll help you, Teflon. We're going to make a fraction. I divided by 1. All right, cross multiply Teflon. dy times 1 on the left-hand side is going to be?
dy equals 3 minus y dx.
There it is. that quantity of 3 minus y dx. All right, and this is going to be a little bit tricky to isolate because I have this 3 minus y. Let's just go ahead and divide by this whole 3 minus y. I think that might be the easiest way to do this. So if I do that, I'll just write the answer here. This is going to be 1 over 3 minus y dy is equal to dx. All right, so Teflon and I have separated the variables, pat ourselves on the back. I have to get to this hard stuff, because otherwise.
Hey, Mr. Sindel.
Yes.
What about the cosine of x?
Whoa, I didn't even see that. Yes, sorry. Thank you. That should be over here. Thank you, thank you. Log it. That's extra credit right there. Cosine of x. So I really have cosine of x dx. Good catch. That would have changed everything. All right. So from here, I think we're good so far. Let's do step number 2. Step number 2, Fiona, help us out.
Integrate.
Integrate. I'll slap on the integral symbols for you. Integral of, I'm going to recall this 3 minus y to the negative first power. Negative first power dy is equal to the integral of that cosine of x dx. Okay, how do we do this, Fiona?
Is it 3 minus 3 minus y, then, oh wait, is it natural log of the absolute value of 3 minus y?
You're really close. So you caught the fact that it was a natural log house, but there's an additional trick here too, which is taxman. You have to use taxman. Why? Because the derivative of the inner is not 1, it's -1. So if you want to do taxman really quickly in your head, just add the negative and you're done. So negative natural log of absolute value of 3 minus y and absolute value. So good job catching loghouse, but again, taxman is going to add this additional negative out front. So good job on the left-hand side. Can you do the right-hand side for us as well, Fiona?
Sine of x.
Sine of x.
Plus c.
Plus c. You got a whole nother point just for writing that plus c. Nice. Yep, and anti-change means it's the same sign, so we don't have to change it from positive. It's still positive. That's integration. Done. Step number 3. Here we go. Step number 3 is to do what, Teflon?
Evaluate.
Evaluate. Oh wait, I haven't talked to Andrea yet. Andrea, do all the evaluation for us.
The negative natural log of the absolute value of 3 minus 1 equals sine of 0 plus c.
There it is. Yep. Yep, and that's just using our initial conditions up here. X was 0, Y was 1. All right. Keep going, Andrea. Go ahead and just solve for C for us. And this one, it's not that easy. I'll help you once we get to the hard part, though. So far, do like sine of 0. What's sine of 0?
Is it 0?
It is indeed 0. Yep. So this thing is 0. So don't worry about that. And I'll do the hard part. 3 minus 1 is 2. Whew. All right. So from here, I'm trying to think. My notes from last year are wrong. I can't look at those. I'm going to have this negative natural log of 2. Absolute value of 2, by the way, is 2. So I can drop the absolute value sign. I know that that's 2. Is equal to C. Wait, That wasn't hard then. Yeah, we've solved for C. There it is, negative natural log of 2. Okay, and we are now finally on to step number 4, and I'm going to need a lot of room. I think I'm going to start right here, and I'm going to eventually move to the right-hand side. Step number 4, which is to isolate. And isolating has a lot of stuff. So we know that we have negative natural log of 2. I'm going to plug that in to our equation up here. So we have negative natural log of absolute value 3 minus y and absolute value is equal to sine of x and then minus natural log of 2. So far, so good. Nothing too tricky so far, aside from the tax man, the natural log house. I think that was the trickiest part so far. So this is the new stuff. How do I solve for y? How do I isolate y? That's what the step that we're currently on, and it's trapped. It's trapped in 2 different hard things to get rid of. It's trapped inside of a natural log, and at the same time, it's trapped inside of absolute value. How do we undo both of those things? And you might have seen them before. I think you have. To get rid of natural log, you do e to the power of e to the power of on both sides. So e, and this is now a power of negative natural log of absolute value 3 minus y, is equal to e to the power of sine of x minus natural log of 2. This is called, you don't need to know the name, I'll write it down just in case you want to know and talk about it with your college friends. It's called exponentiation. Exponentiation, and of course I run out of room. Exponentiation, we're exponentiating each side. Why does this work? Well, check this out. I guess I should have got rid of the negative sign right now. Let me do that really quickly. I'm going to magic it away. I'm going to multiply both sides by -1. This is now a positive. This is now a negative. This is now a positive. E to the natural log of x, and this is just a rule that was in our cheat sheet for logarithms. E to the natural log of x is equal to x, which is another way of saying e to the natural log of each other cancel each other out, and the answer is whatever the exponent was, which means e to the natural log of absolute value of 3 minus y is whatever this power is. It is now, right, different color, the absolute value of 3 minus y. That is the new left-hand side after exponentiation. The right-hand side, unfortunately, is still exponentiated. It is still this e to the power of negative sine of x. And there's a trick I'm about to do. There's going to be a lot of tricks like back to back to back. So yes, I could write plus log of 2 or in the power, but there's this other rule of exponents that states this. If I have a to, let me do x to the power of a plus b, this is the same thing as x to the power of a times another base of x to the power of b. As long as the bases are the same, you can separate this with a multiplication symbol, which will help us, and you'll see why in a second. So I'm going to say this is now e times another base of e to the power of natural log of 2. So you're allowed to split these powers apart using rules of exponents. Let that sink in for 5 seconds. And there's 5 seconds. So there's something else that's cool. Check this out. E to the natural log, which I just talked about, those cancel each other out. E to the natural log cancels each other out, and this is now just 2. So our next line down here is going to look like this. This is going to be, what color am I on? Black, I guess. 2, I'm going to write the 2 out front. I guess I could write it out to the right, but it's kind of weird to put a number out to the right. So this is 2 times e to this negative sine of x. And on the left-hand side, nothing has changed. We still have this absolute value of, well, actually, we can go ahead and start getting rid of this absolute value symbol. I know that there's so many tricks back to back, but it's calculus, welcome to it. Okay, so to get rid of this absolute value symbol, there is another rule that you have to have memorized, which is this. If I have the absolute value of x is equal to, I don't know, some number, I'm just gonna say number, pound symbol, octothorpe, whatever you want to call this thing. If x is equal to some number, those are supposed to be absolute value symbols. They look like parentheses. Let me redo this. If this is absolute value of x and I want to get rid of it, what you do is you just get rid of it and you say this is now plus or minus that number. which technically is two different equations. But for us, we're just going to leave it as one equation and just write the plus or minus. That's how you get rid of absolute value symbol. So we get rid of it, 3 minus y. Ooh, got rid of it. But on the other side, this right-hand side, we now need to write a plus or minus symbol. And guys, we're almost done. I see why. I see it right there. It's almost by itself. Let's go get him or her. I don't know. Let's subtract 3 from both sides. So minus 3. Let me do it on a separate line. We've done too many tricks altogether. So I have plus or minus. Let me switch to red. Plus or minus 2e to the negative sign of x minus 3. And that's equal to a negative y on the left-hand side. And finally, I'm going to multiply everything by a negative, and I get our final, almost final answer. I need some room here. This is y is equal to, technically it should be minus or plus. Now it doesn't really matter. You can say plus or minus. Minus or plus 2e to the negative sign of x plus 3. Again, all the signs change over here because I multiply by a negative. There are quite a few tricks here, and we still are not done because I have only done 3 of the 4 steps. I need to finally verify, hey, which one of these symbols is it? Is it a minus or is it a plus? So we have to go back to our initial conditions where x is 0 and y is 1. Y is 1 and x is 0. So this whole power up here is going to be 0. So this is going to be 1 is equal to minus or plus 2e to the power of 0 plus 3. Anything to the power of 0, you guys will all hold up the number of fingers. Is it 0 or is it 1? Anything to the power of 0, it's 1. Good, yeah. So this e to the power of 0, we can cross this guy off and say that's really 1. So 1 is equal to minus or plus 1 plus 3. And clearly we have messed up somewhere. Oh wait, why am I saying 1? 2. 2 times 1 is 2, not 1, Mr. Sindel. Good job. I should have paused and let you guys catch it for the extra credit. I apologize. Clearly, we have a negative here. A negative 2 plus 3 is a positive 1. If this was a positive, then this answer over here would be 5. So the negative is the right answer, which means we can count all the way back and we can write out our final answer. Y is equal to, I'm just going to kind of circle this and that's our answer. Y is equal to negative 2e to the negative sign of x plus 3. Whew. And again, about 50% of the problems I've seen on the AP test are about that level of difficulty, and we got about 2 points right there. I talked really fast. I did a very, very hard problem with many, many hard twists and turns. This is the nerve-wracking point where I ask, how well did you follow that with a fist of 5? That step 4 specifically. Oh, okay, not too bad. 3 for Fiona. 3. Okay, everyone has a 3. And that's a good score. That was a lot of hard work, and I will be giving you some practice on this. Is there an assignment worksheet 6-3? I don't know if I made one because this was an optional lesson. Let me remember. Let's go. AP Calculus. Did I do a worksheet 6? Oh, I did make one. What does that look like? Oh, I just have you do the first 3 steps over and over again. Yep. So I'm just, it's basically 6-2 homework times 2 now, because I'm not making you do the 4th step in worksheet 6-3. Yeah. So you are basically all giving me a 3 on our objective as well, because that's how well you understand that hardest question. But there it is, girls. Good job hanging in there. And that concludes the lesson.